data type variable to like this, n number of variables. After that, n number of methods. Now we'll create object like this. In this line, what is EMP here? What is EMP? Class name. What is E? Object reference. What is new? Dynamic memory allocation operator. Okay. See, in this line, what is EMP once again? Class name. What is E? Object reference. What is new? Dynamic memory allocation operator. What it will do? Say, whatever I given, those all you have to remember. You should not forget. Concept to concept relation will be there yesterday onwards. Okay. Okay. I'll ask some questions. Give me answer first of all. Is Java object-oriented programming language? Yes. What is object-oriented programming language? Which supports all object-oriented principles. How many principles are there? 4. What are those? Encapsulation, abstraction, inheritance, polymorphism. If you want to use these 4 principles in Java programming, first what we require? Class and object. Class and object required. What is class? Class is a collection of variables and methods. Class is a collection of variables and methods. Will it class occupy memory? No. Will it file occupies memory? Yes. What is object? Instance of a class. Instance of a class. Yesterday I given this syntax to create an object. Here, what is this? Class name. What is this? Object reference. What is this? Dynamic memory allocation operator. What it will do? It allocates a memory to variables. Okay. It compile time allocates or runtime allocates? Runtime. What is this? Constructor. What this constructor will do? Constructs the object. Say, whenever this line is executed, in this line, first of all, new executed. New is a dynamic memory allocation operator. It allocates the memory to these variables. So 3 variables memory allocated, like employee number, name, salary. Okay. Like this, employee number, name of the employee, salary of the employee. You written yesterday, no need to write. Listen. Employee number something 101, name of the employee, after that salary of the employee. Now, say in this line, first new executed. It allocates the memory to variables like this. After that, constructor executed. Constructor constructs the object. Here, object created. Employee object created. Okay. After creating object, every object has an address. The address mapped into another code. That code implemented with hashing technique. That code is called as one hash code. Okay. This is hash code. This hash code stored in E. Here, that hash code is going to be stored. Now, like this, stored. This reference refers object. So instead of writing these numbers, further what I'll do is I'll give arrow mark. With that arrow mark only you can understand. And this object referred by this reference. Okay. Further, this type of addresses I'll not give, because that is only we cannot predict number. What is going to be stored, we cannot predict. That's what I'll give only arrow. Arrow meaning is that object referred by that reference, like that. Okay. This object referred by reference. This object referred by reference. Then object reference. Now, this is I given yesterday. In this line, new is called dynamic memory allocation operator. It allocates the memory to variables. After that, constructor constructs constructs the object. After creating object, that hash code stored in E. Okay. This is I given yesterday. Suppose if I write only like this, new employee, if I write, now also object created. If I write only new employee, also object created. Say new. It is a dynamic memory allocation operator. Memory allocated. New is called dynamic memory allocation operator. It allocates a memory. Employee number, name, salary. Now allocated. Suppose employee number, name of the employee, and salary of the employee, like this. Okay. Now constructor. Constructor constructs the object. It is like an object. It is like an object. Employee object. This object has an address mapped into another code. That code is called hash code. Now what is the difference between yesterday and today? This one you observe. Yesterday, this hash code maintained in object reference, but now hash code not maintained. So your hash code is there, not referred by any reference. Your object is there, not referred by any reference. This type of object is called anonymous object, or we can also call unreferenced object. Anonymous object, or we can also call unreferenced object. Say, example, building constructed, not registered with GHMC. Building constructed, building is there, but not registered. That type. Building constructed, but not registered. Object is created, that is not referred by reference. See, in Hyderabad, so many buildings are there, not registered. That type of buildings are there, no? Illegal buildings. Now, building is there, but that is not in the government record. That type of buildings are there, no? Like that. Here, anonymous object. Object is created. That object not referred by reference. That type of object is called anonymous object, or we can also call unreferenced object. This type of objects also required in programming. So if you write like this also, object created. Write this one. New constructor. If you write also, object created. Your object is created, but that object not referred by reference. This type of object is called anonymous object. We can also call unreferenced object. So new constructor, if you write, object created. This type of object is called anonymous object. We can also call unreferenced object. This object. So this object is an instance of employee class. The word instance, it is nothing but one incident. Before constructing building and after constructing a building, that incident happened, no? Plan. Based on that plan, building constructed. This building is an instance of that plan. This object is an instance of employee class. Like that we'll call. It is just technical word. Okay. This object is an instance of employee class. That is the word instance. Now, if you write like this, object created. Suppose if you write like this, if you write only like this, now object is not created. That is object reference created. In this case, what will happen? Only E memory allocated. E memory allocated. But in this, hash code is not there, null will be stored. This is called object literal. Object is there, hash code stored. Object is not there, object literal stored. That is null. What is the use of null is this one. So EMPE if you write, then E memory allocated, in that memory no hash code. What will be stored? Null. That means there is no object. That is object literal. So you studied how many categories of literals are there? 6. What are those? Integer literals, floating point literals, character literals, string literals, boolean literals, object literals. Object literal is null. Object is there, that hash code stored. Object is not there, null stored. That null only object literal. Write this one also. So if you write like this, it is like this, memory allocated. So if you write like this, memory allocated like this. EMPE, if you write, E contains null. Null is nothing but object literal. That meaning there is no object. Is it over? No. Is it over? So EMPE, if you write, E contains null. Null is nothing but object literal. Now I'll ask some questions, give me answer. Can we create object without object reference? Can we create object without object reference? Yes. That type of object is called anonymous object. We can also call unreferenced object. Unreferenced object. Can we create object reference without object? Yes. That object reference, what it contains? Null. What is null? Object literal. Object is there, hash code stored. Object is not there, null will be stored. Okay. This is, remember, these are just outlines of class and object. Okay. Now, what is class? Class is a collection of variables and methods. Variables and methods, if it is completed, then class completed. But variables, methods not completed. So next write it. Variables. This is a given definition. A variable is a container that contains data. This definition only are given. Remaining all I'll explain now. Definition, declaration, assignment, initialization are given. Now here you will study all types of variables also. Variables. A variable is a container that contains data. A variable is a container that contains data. Say, if I write integer x equal to 10, if I write in this line, which is variable? X is a variable which contains 10. That's what it is called, container. Okay. X is a variable which contains 10. That's what it is called, variable, container. So X. X which contains 10 data. Okay. Now in this line, X is a variable which contains data. That's what we are calling container. Now this is you studied already. Next, in Java, there are three types of variables. First one, instance variables. Second one, class variables. Third one, local variables. In Java, there are three types of variables. First one, instance variables. Second one, class variables. Third one, local variables. First of all, I'll give a notes. After that, with the diagrams, I'll explain. Now, instance variables. First one, instance variables. A variable that is defined as a member of a class is called as an instance variable. A variable that is defined as a member of a class is called as an instance variables. A variable that is defined as a member of a class is called as an instance variable. Memory allocated to instance variables. Memory allocated to instance variables whenever an object is created. Memory allocated to instance variables whenever an object is created. Instance variables are stored in heap area. I'll explain each and every point. Just write the notes only. With the diagrams, with the examples, programs, I'll explain. A variable that is defined as a member of a class is called as an instance variable. Memory allocated to instance variables whenever an object is created. Instance variables are stored in heap area. Second one, class variables. A variable that is defined as a static member of a class is called as class variable. A variable that is defined as a static member of a class is called as class variable. A variable that is defined as a static member of a class is called as class variable. A variable that is defined as a static member of a class is called as class variable. Say, instance variable definition, class variable definition, if you observe, only static keyword. Okay. What is static keyword? Not complete. I'll explain. Now, a variable that is defined as a static member of a class is called as class variable. Memory allocated to class variable whenever class is loaded. Memory allocated to class variables whenever class is loaded. Class variables are stored in method area. 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 Just note down, I'll explain what is method area, what is heap area, I'll explain. Third one, local variables. Local variables. A variable that is defined inside a method is called as local variable. A variable that is defined inside a method is called as local variable. A variable that is defined inside a method is called as local variable. Memory allocated to local variables whenever method is called. Whenever method is called. Local variables are stored in stack area. 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 Note 1. Local variables cannot be static in Java. Note 2. No global variables in Java. No global variables in Java. No global variables in Java. Is it over? See. What are the points I given? These all points with the diagrams, with programs, examples I'll explain. See, it is the most important topic in the entire Java. You concentrate more and more and you put efforts, work hard to understand. Okay. Total Java depends on this topic only. Total Java depends on this topic only. Okay. Now here each and every point important only. Now I given. First you see the notes and give answer. After that I'll explain. Now see the notes and give answer. Questions are not there, but answers are there. Okay. You can give answer. It is possible. See. How many types of variables are there? 3 types. What is the first one? Instance variable. Second one, class variable. Third one, local variable. See, what is instance variable? Member of a class. Member of a class. What is class variable? Static member of a class. That is member of a class. This is static member of a class. What is local variable? Inside a method. Inside a method. When memory allocated to instance variables? Whenever an object is created. When memory allocated to class variables? Whenever class is loaded. When memory allocated to local variables? Whenever method is called. Method is called. Now, in the CPU, 2 memories will be there. Primary memory, secondary memory. Primary memory nothing but RAM. Secondary memory nothing but hard disk, ROM. Okay. Like primary memory like a RAM, secondary memory like a hard disk. Primary memory, temporary memory. All operations are done in RAM only. Secondary memory, hard disk, permanently stored in the data in a hard disk. Now, but your programs are executed in a RAM only. Without RAM, we cannot work on computer. But without hard disk also we can work. Without RAM, not possible. That's what it is, primary memory. Now, that memory, suppose, what will happen, you observe. Here I open Google Chrome browser. I open Zoom software. I open Notepad. In the RAM, what will happen? Some memory allocated to Notepad, some memory allocated to Zoom software, some memory allocated to browser. Like that, our Java program also some memory allocated. That memory called JVM memory, Java Virtual Machine Memory. Okay. That memory divided into 5 blocks. There are 5 memory blocks in JVM. That is, while teaching JVM architecture, very depth I'll explain. Present, you write this one. There are 5 memory blocks in JVM. There are 5 memory blocks in JVM. First one, method area. Second one, heap area. Third one, stack area. Fourth one, PC registers. Nothing but program counter registers. Program counter registers. Fifth one, native stack area. There are 5 memory blocks in JVM. Method area, heap area, stack area, PC registers, native stack area. Program counter registers. There are 5 memory blocks in JVM. Method area, heap area, stack area, PC registers, native stack area. Now, these 5 memory blocks, you observe. Now, I given present 3. Remaining 2 you will study while teaching JVM architecture. At that time, I'll explain. These 3 present, you concentrate. So, in a CPU, RAM will be there, ROM will be there. RAM is primary memory, ROM is secondary memory. In a RAM, some memory allocated for JVM. That memory called JVM memory. That memory divided into 5 blocks. These 5 blocks, instance variables are stored in heap area. Class variables are stored in method area. Local variables are stored in stack area. Like that, it is going to be stored. Okay. Next one. Local variables cannot be static in Java. No global variables in Java. Global variables, nothing but outside the class. In the bracket, write it better. Outside the class. Note 2. Note 2 place only write it. In the brackets, outside the class. No global variables in Java. Outside the class. Now, I'll explain with the diagrams. Here, today variables are not going to complete. Tomorrow also it will not complete. Day after tomorrow, 3 days it will take. Okay. Until 3 days, you should have a patience to understand this subject. It is the most important. See, like how to identify instance variable, class variable, local variable. After that, what is the difference between instance variable, class variable, local variable? And when memory allocations diagram also. After that, how to access them? What is the scope? What is the life? Like that, so many concepts are there. Okay. Each and every concept you have to learn. This topic, if you are perfect, later any Java program you can write. Any Java program. That's what. Every point important only. It will take 3 days to explain only variables. Okay. Now, first, how to identify, I'll explain. How to identify, I'll explain. Say, first, this class and the main method, it is common. Okay. Without class, we cannot develop applications. That's what class name, open brace, close brace, compulsory. Without main method, we cannot execute program under operating system. That's what main method, open brace, close brace, compulsory. This is common code for every program. Okay. Now you observe. Here, I'll write some variables. You observe. Int A equal to 10. Static int B equal to 20. After that, int C equal to 30. static int d equal to 40. Now again here int f equal to 50. Static int f equal to 60. Like this I written. Now you observe. Okay. Now like this I written remaining dash dash. It is just code snippet, not a complete program. Now outside the class two variables are written and non-static static. Inside the class outside the methods two variables are written non-static static. Inside a method I written two variables non-static static. Total 6 variables are written. Now first of all there are how many types of variables? 3 types of variables. What is first one? Instance variable. Second one class variable. Third one local variable. I given definition. Instance variable. What is instance variable? Member of a class. Member of a class. Now you observe C. C is a member of demo class. Don't write. I'll give you time for writing. Listen. Now C is a member of demo class. Here C is a member of demo class. Okay. Here C is a member of demo class. It is called instance variable. Next, static member of a class. See, D is a static member of demo class. You observe here only static keyword is additional. Okay. Member of a class is called as instance variable. Static member of a class is called as class variable. Inside a method, it is called local variable. Inside a method, local variable. Note 1 I given. Note 1. What I given? See, local variables cannot be static in Java. In other languages possible, but Java doesn't support. Now, main is a method. Inside a method, if you write a variable, it is called local variable. It is also local variable, but local variables cannot be static in Java. So this is not valid. Error. Okay. Note 2 I given. Note 2. What I given? See, no global variables in Java. Global variables are nothing but outside the class. It is a class. It is outside the class. No. Outside the class, you cannot write variables in Java. Other language supports, but Java doesn't support. Outside the class, if you write variable, error. If you write non-static, also error. If you write static, also error. So out of 6 variables, 3 only valid here. 3 not valid. So here, if you write a variable outside the class in Java, it's an error. It is also error. It is valid. It is valid. It is valid. This is invalid. Okay. Now, 3 variables are valid. 3 variables are not valid. Now, C is a member of demo class. It is called as instance variable. Instance variable. Okay. D is called as class variable. D is called as class variable. E is called as local variable. Now, inside a class, outside the methods, inside a class, outside the method, instance variable. If you write static keyword, class variable. Inside a method, if you write local variable, but inside a method, static is not allowed. Outside the class, static also not allowed, non-static also not allowed. Now, these are identification. Suppose if I show one Java project, in that project, which are instance variable, which are class variables, which are local variables? If I ask now, is it possible or not to identify? Possible, no? That is just identification completed. Okay, write this one. Now, if I show any Java project, if I ask, you should be able to give answer. Possible, no? No. Write this one. I written 6 variables. Out of 6, 3 only valid, 3 invalid. Out of 6, 3 variables are valid, 3 variables are not valid. Is it over? Now, if I show any Java project, in that project, which are instance variables, which are class variables, which are local variables, if I ask, can you give answer or not? Possible, no? Say, inside a class, outside the method, those are instance variables. Just a static keyword if you attach, class variables. Inside a method, local variables. Inside a method, if you write static, error, not valid. Outside the class, variables are not allowed. Okay. Now, you can identify variables. Now, memory allocations I'll explain. Out of six, valid variables only I'll write now. Here. Suppose integer x equal to 10. Static integer y equal to 20. Integer z equal to 30. Now x which type of variable? Instance variable. Y which type of variable? Class variable. Z which type of variable? Now you can identify. Okay. Now x is listen with more concentration. Discussions after class you can discuss. While teaching only if you discuss what is the problem I explained. Okay. While teaching only if you discuss you will not get a subject. First you listen the class. After class what you understood, what your friend understood, you can discuss later. Okay. Now only if you discuss, you are not listening, your friend is not listening. Later discussion also nothing, no use. Okay. Now only if you discuss. Now with the discussions more knowledge comes. I'll accept. Not now. After class. Listen. Now x which type of variable? Y which type of variable? Z which type of variable? You can identify. When memory allocated to instance variable. When memory allocated to instance variable. Whenever an object is created. When y variable memory, class variable memory allocated. Whenever class is loaded. When local variable memory allocated, whenever method is called, that is a given. Here you should know your execution priority. Now just note down execution priority. Execution priority. First one, class variables. Second one, static blocks. Third one, main method. First one, class variables. Second one, static blocks. Third one, main method. Execution priority. First one, class variables. Second one, static blocks. Third one, main method. Here, first what will happen is, whenever you run the program, first class variables memory allocated, next static blocks executed, next main method executed. Static blocks till I didn't explain, that it comes further. Okay. Now in this program, it is class variable, main method. This is main method. So if I run this program, first of all, give me answer. This class name is demo. Suppose file name is test.java. Valid or not valid? Class name demo. File name test.java. Valid or not valid? Valid. Then how to compile this program? C:/Java test.java. How will run? Java demo. Java demo or Java test? Java demo. Okay. Now here what will be happen? Just you observe, file name can be any name, but you are running with class name. Then what will happen? This demo, nothing but this demo. If you write Java demo class loaded into memory. So whenever you run Java demo, then demo class loaded. Whenever class is loaded, class variable memory allocated. And after that, main method called. Suppose in your program, class variables are not there, then main method called. So first what will be happen here? Class variables executed. Next static blocks executed. Next main method executed. In the main method, whatever order you return, that is executed. Like that it works. So suppose in your program, class variables are not there, then static blocks executed. Suppose in your program, static blocks also not there. Next, main method executed. Suppose in your program, main method also not there. Execution not started. Okay. So that is execution priority. First a class variable, next a static block, next a main method. That order executed. It will search for class variables we have. That is executed. Next, it will search for static blocks. We don't have. Next, it will search for main method. We have. That is executed. In the main method, order executed. First, whenever method is called, local variable memory allocated. That is executed. But still, X memory not allocated. When X memory allocated, whenever object is created. Suppose if you don't create object, no memory for that. That is the reason yesterday given class will not occupy memory. So here yesterday I written only instance variables all, employee number, name, salary. Those three variables are instance variable. That's what no memory. If you create object, then only memory for instance variables. So if you don't create object, no memory for class. That's what I'll write here. Demo. Now you studied syntax to create an object. First, what we have to write? Class name. Next, object reference. Next, new. Next, class name brackets. Nothing but constructor. Suppose one more time. Demo D2. New. Demo. One plan. N number of buildings you can construct. one class, n number of objects you can create. Okay, like this are written, remaining dash dash. Now you observe. Now you observe this program memory, how it is going to be allocated. Just you observe. First, demo class loaded, open brace executed, class variable memory allocated. This is going to be stored in method area. After that, main method called, open brace executed. It is going to be stored in local variable stack area. Next, in this line, new executed. What is new? Dynamic memory allocation operator. What it will do? It allocates a memory to variables. Yesterday, I didn't explain types of variables. That is the reason just variables I said. But actually, it allocates the memory to instance variables only. That is the reason. Today, once again, write that point. New. It is called as dynamic memory allocation operator. It is called as dynamic memory allocation operator. And it allocates a memory to instance variables at runtime. It is called as dynamic memory allocation operator, and it allocates a memory to instance variables at runtime. It is called as dynamic memory allocation operator, and it allocates a memory to instance variables at runtime. Say, what is new means? Dynamic memory allocation operator. What it will do means it allocates a memory to instance variables at compile time or runtime means runtime. Execution time allocated. That is called dynamic. So while executing only memory allocated in Java, that's what dynamic we are calling. That is only we are calling like a runtime also. Now, this is first. What will happen? See, new allocated allocates the memory to X, and the constructor constructs the object. Object created in heap area. Heap area created. That hash code stored in D1. Okay. Now, this D1 is the object reference. Now, this demo is a class. Now, I'll ask one question. Give me answer. I'll ask some questions. How many categories of data types in Java? How many categories of data types? 2 categories. What are those? Primitive data types, reference data types. How many primitive data types are there? 8. What are those? Byte, short, int, long, float, double, char, boolean. What are reference data types? Arrays, strings, classes, interfaces, dash dash, etc. Many we can create. So many are there. Enumerations and records, so many are there. We can create. Now, I'll ask one question. Give me answer. Class, can I call data type? Class, can I call data type? Yes or no? Yes. Just now I given reference data types. What are those? Arrays, strings, classes, interfaces. So class is a data type also. So class, we can call it as data type also. Is it primitive data type or reference data type? Reference data type. Whenever this is called as class, it is called as object reference. Whenever it is called as data type, it is called as variable. So object reference, we can call it as variable also. Okay. Now, note, class can also be called as reference data type. An object reference can also be called as reference variable. Class can also be called as reference data type. And object reference can also be called as reference variable. Class can also be called as reference data type. And object reference can also be called as reference variable. Class can also be called as reference data type. And object reference can also be called as reference variable. So class we can call it as object reference data type. Object reference we can call it as reference variable. Now, is it over? Now, here what is int? What is int? Data type. Data type. What is z? Variable. It is primitive data type or reference data type? Primitive data type. It is primitive type variable or reference type variable? Primitive type variable. What is demo? Demo is a class. Can I call data type? D1 is a object reference. Can I call variable? Is it primitive type variable or reference type variable? Reference type variable. Okay. This one you can call it as class also, data type also. This one you can call it as object reference also, variable also. Now it is reference data type. It is reference variable. What z contains? What z contains? Data 30. What D1 contains? What D1 contains? Hash code. Hash code. So primitive type variable contains data. Reference type variable contains hash code. Write that one. Primitive type variable contains data, whereas reference type variable contains hash code. Primitive type variable contains data, whereas reference type variable contains hash code. Primitive type variable contains data, whereas reference type variable contains hash code. Primitive type variable contains data, whereas reference type variable contains hash code. Primitive type variable contains data, whereas reference type variable contains hash code. Now you observe. Here, what is int? Data type. What is z? Variable. What is demo? Class. What is D1? Object reference. This one, can I call it a data type? This one, can I call it a variable? Yes. This one, can I call it a class? No. This one, can I call it an object reference? No. Okay. Now, is it primitive data type or reference data type? It is primitive type variable or reference type variable. This is what it contains? Data. What it contains? Hash code. Clear no? Now, how many types of variables in Java? 3 types. What are those? This is which type of variable? 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 Is it primitive? Is it instance variable or class variable or local variable? What is this? Local variable inside a method. This is reference type variable only, but it is local variable. Okay. So this is also local variable. Okay, this is also local variable. Now I'll explain with a diagram. Just you observe. Here, memory blocks. 3 memory blocks. Method area, stack area, heap area. Listen with more concentration. Now, first, demo class loaded, open brace executed. Next, static into y equal to 20. That is stored in method area. Y 20. Okay. Now, demo class loaded, open brace executed, execution priority class variables. So, first class variable memory allocated in method area. After that, static blocks. We don't have static blocks in this program. After that, main method called, open brace executed, local variable memory allocated, Z 30. That is stored in stack area. That is stored in stack area here 30. Okay. Now, in this line, first a new executed. It allocates a memory to instance variable X in heap area. X memory allocated. In this memory, 10 will be stored. Constructor constructs the object. Constructs the object. Now, this object referred by D1. Now, D1 is instance variable or class variable or local variable. Which memory block stored? Local variable in stack area. Here allocated. Okay. Now, this object has code stored here. Now, already told, instead of writing number, I'll write arrow. The arrow meaning this hash code there. Okay. Like this. Again, new. Again allocates a memory X. Again 10. Now, constructor constructs the object. Demo object. This object referred by D2. Like this. Now, in that program, X appears only one. But actually, how many X's are there? 2 X's. If I create 100 objects, how many X's will be there? 100 will be there. Every object separate copy. But Y, only one Y. Okay. Z is different, depends upon calling, depends upon multi-threading, many will be there. That later we'll see. First, X and Y you observe. If I create 100 objects, how many X's will be there? 100 will be there. How many Y's will be there? 1. That is, remember, I'll give notes. First, you write this diagram, write that program, write the diagram, that code snippet and diagram, write it. This is about memory. How to identify your seen memory allocations you have seen. How to identify your seen memory allocations you have seen. How to access them, I'll explain. Is it over? If I create 100 objects, how many copies of instance variable created? 100 copies created. If I create 100 objects, how many copies of class variable created? Just one. Okay. No. That point I'll give. First, is it completed? See, once again I'll explain. Listen. Demo class loaded. Open brace executed. First, it will search for class variables. Static int y equal to 20. It is stored in method area. And after that, it will search for static blocks. We don't have static blocks. Then it will search for main method. We have main method, open brace executed. Whenever method is called, local variable memory, integer z equal to 30, it is stored in stack area. After that, in this line, first new executed. Whenever new executed, memory allocated to instance variable x. Constructor constructs the object. This object hash code stored in D1. So D1 is local variable stored in stack area. Again new, again allocated memory to x. Constructor constructs the object and that object referred by D2. This hash code stored in D2. So here two objects are there, 2 copies of x. If I create 100 objects, 100 copies of x. But class variable 1 copy. Okay. Now that notes I'll give. First, is it completed all students? No. Write this one. Separate copy of instance variable exist for every object. Separate copy of instance variable exist for every object. Separate copy of instance variable exist for every object. Only one copy of class variable exist for all objects. Separate copy of instance variable exist for every object. Only one copy of class variable exist for all objects. Separate copy of instance variable exist for every object. Only one copy of class variable exists for all objects. Now, here, whenever value is same for all employees or all students or all objects, then we have to go for class variable. If the value is different for every object, we have to go for instance variable. I'll ask some questions, give me answer. Employee number, different will be there, same will be there. Then which variable? Instance variable. Employee name, instance variable. Salary, instance variable. Company name, in that company, all employees same name will be there, no? Then which variable you have to select? Class variable. Like that we have to select. Okay. Student roll number, student name, student address, mobile number, mail ID, college name, class variable. University name, like that we have to select. For all employees, same is their class variable. All students, same is their class variable. Different is their instance variable. Like that we have to select. Okay. It is not completed. Tomorrow it will be continued, not completed. Okay. But every point important only you have to remember. Assignment I didn't share. Today I'll share. Today I'll share. Every point important only. Don't neglect this topic. It is the most important topic in the entire Java. Be regular. Every point important.